I'm Pat Stover. I'm the Vice President of Sales here at Annapolis Micro Systems, and we'll be discussing some of our product line today. I'd like to start out by just going into generally what type of products we build. All of our products are built focusing on FPGA processing. As you can see, we have the XMC cards here with Vertex 5s on them, the connectors for the XMC, connectors to the outside world, and also the heatsink on top of the main processor here. All our PCI X controllers or PCI Express controllers are built by Annapolis, and they are built within a Vertex part. Besides the XMC, we also step up to the Wildstar 5 PCI Express board. Underneath here are 3 programmable elements. We give you great flexibility, and we allow you to put whatever type of FPGA you want here, from the LX, FX, or SX parts in any of the positions, along with the associated memories. And they can get different types of that. You can get DRAM, SRAM, or QDR, and even some reduced latency. The heatsink and the fans provide us great thermal capacity for our boards, and allows us to operate these PCI boards, or PCI Express or PCI X boards, in environments that don't have much airflow. Also, you'll notice right here we have 2 rows of connectors. This is where we install our I/O cards. Here's an example of a 4-channel 10 gigabit Ethernet I/O card. It would plug right here, as you can see, plugs right in there, and that way you have 4 channels coming directly to this, and these are fully bidirectional. You can also see that it has connectors on top. We also can plug in an ADC card, stackable. This gives you the capability of bringing data to the card as well as dispersing it through 10 gig E. This all fits in a single slot of the PCI Express environment. This will take the second slot but draws all its power from the main board. Some other features of this board is that it has the external power connector that you can connect directly to the power supply, therefore not having to rely on the power distribution on the PCI Express backplane. Next, we step up to the VME environment. Same number of processing capability, but a much more rugged environment. Also, it doubles the capacity for the I/O connectivity. We can put up to 4 I/O cards on this card, once again stacking, or in a single slot having 2 I/O cards, either the SerDes type Rocket I/O interfaces or the A to Ds. We build a wide range of these A to Ds, everything from 100 megahertz up to 5 gigahertz, single and multiple channels. So the VME also has a 1 PPS input from the outside world, as well as an Ethernet. You can plug directly into this board to update it. Typical VME or VXS capability, all once again with Vertex 5 parts on it, and the different memory options as you can see in the chart below. Buses between all the FPGAs so you can move the data. The great thing about these designs is it allows us to sample at full rate with our ADCs or our serial I/O cards and not have to reduce the data. Keep the data moving on and off the board at full rate. An example is in our PCI board, through the PCI Express bus interface, we've been able to move data from an ADC card through the FPGA fabric out to the host memory bus at up to 1.8 gigabytes per second. Very fast DMA performance. So we talked about kind of the standards. Our newest product here is a standard also that's built for the IBM Blade environment. This is a 2-slot configuration here. Underneath it, you'll find up to 8 modules, FPGAs or Telera chips, the Pro 64. This happens to be an FPGA in either, once again, the selection of part sizes, SX, LX, or FX, in any of the positions, as well as the Telera Pro 64s in 6 of those pluggable positions. So this would plug right in.